from my tutor.
Oh, Bobby. Um, and and did Bobby get 3 root 3? I forget what you had said originally, Ryan.
Yeah, that was the right answer.
Okay. Okay, good. Um, yeah, super cool problem, but um I feel like it takes too much time and it may be a lot of people might not get it if I put that on. But awesome problem too, like an awesome challenge problem. Okay, Nilesh, back to you. 5 points. Let's do 5.7. What number was it again?
Yeah, number 5.
Okay, let me just open it up. Hold on a sec. Um, Yeah, sometimes that problem, but I think it's in my calc class that sometimes I have given that as a practice problem. Like I gave you guys some practice, but they were better off for in class than on a test. Okay, 5.7. This is the log graph after extra practice, right?
Yeah,
All right, which one?
number 5, where there's like
Oh,
inequality.
oh yeah, yeah, yeah. Okay, yes. So this you want to be careful about the graphing for this. So I restricted the domain to only x greater than or equal to 0. So let's think about, and I can show you what the graph looks like if it's not the case, but always good idea. We know the domain greater than or equal to 0. What's the range then of this? Like if I'm putting 0 to infinity in for x.
The range of the quadratic or the range of the
Let's do the
thing?
range of the quadratic first, actually, because that'll be,
Mm, mm, negative infinity to 1.
yeah. And 2 to negative infinity gets really close to
0.
0, and 2 to the 1 is just 2.
Yeah. Yeah.
Okay. And when does it achieve that high value of 2? At what x value?
Um, like when x is the square root of 2?
So
Or-
we just said that the high value of this function would be 2. So what x value would give you that high value of 2?
Oh, sorry, 0.
Yeah, 0, right. The vertex, right, of the parabola. So 0, yeah. So the high value will be 0, 2. And then looking if whenever a range of an exponential is something with a parentheses, what do you think is going to exist at that value versus having a bracket? What do
Um,
exponentials sometimes have?
Wait, sorry, could you say that again?
Yeah, so sometimes like people often ask when how they can find this certain something of an exponential function, and I always say, well, look for the range. If there's a finite number that has a parentheses with it instead of a bracket, that's where what will
Oh,
be.
the asymptote.
Yes, exactly. So it's going to look like this. Does that make sense?
Yeah.
And actually we can plot another point, which may be helpful for us since we have to do the inverse. Like when I put in 1 for x, what's the y value?
Mm, it is 1.
Yeah. So we know 0, 2, and 1, 1. Okay. That just may be helpful for us. Okay. So does that make sense for graphing the exponential?
Yeah.
Okay, perfect. Now find and graph the inverse. So
I
let's,
know how to get the inverse, I just didn't know how to graph it.
okay. So tell me what the inverse is when you got it.
Oh, uh, well,
All right.
I didn't.
Okay, we'll do it together.
Yeah.
Actually,
Uh,
because I actually think it is a good exercise to go through the inverse because I had to restrict it. Otherwise, there wouldn't be an inverse, right? And so
yeah.
this restriction means the range of my inverse is going to be 0 to infinity, right? Because domain and
Yeah.
range change.
Yeah.
Okay, so switching x and y, let's change it to log form. Log base 2 of x is negative y squared plus 1,
Mm-hmm.
or y squared is 1 minus log base 2 of x, right? So
Yes.
now when I take the square root to solve for y, is it going to be the positive or negative square root based on my restriction?
Positive.
Yes, because I need the output to only be positives or 0, it's going to be the positive square root. You got it. Uh,
Ooh.
is that okay?
Yeah. Oh, I
Okay.
think that's where I messed up with getting the inverse actually. Wait. Yeah.
So one thing that is helpful, like, because if I got this as a function, I just had to graph it. Looking at that, I'd be like, oh God, this is going to be a bit of a pain because, we really haven't done graphs like that. But this is where having done the inverse is super helpful. So so we just said that we know the range is going to be 0 to infinity. What is the domain of this?
0 to 2.
It's going to be right. It's going to be the range of the original. So
Yeah.
now remember with logs, often they have vertical asymptotes. Now looking at this domain of my log, where's the vertical asymptote going to be?
Sorry. Yeah, x equals 0.
Yes. So I'm going to have this asymptote now. And then the points with domain and range, with inverses, domain and range points are x and y's flip. So instead of 0, 2, what's going to be my point on this new graph?
2, 0.
2, 0. Yep. 1, 1's going to be the same, right?
Yeah.
And so this is where the last thing that helped me graph this is the fact that it has to be symmetric across y equals x, meaning if you fold it over this line, it should match up the two graphs. Like, so here's the piece of, actually, maybe do a highlighter so I can show you. Here's the piece of the original. So if I fold the other one, if I'm were to fold it over y equals x, then the other piece would have to be up here. Does that make sense, Nilesh, if I'm starting to graph this?
Kind of.
Because so my red, if I were to fold over this green line, I need my red graph, which is my log graph, should line up with the blue piece. So if I fold it over, it should totally be on top of each other.
Okay.
And so
Yeah.
then that helps me to guide like where this red is versus the blue. And then the other piece is going to be up here. So notice now, well, pretend and good enough. This red piece and this blue piece would line up if I folded over y equals x.
Right. Yeah.
So
Okay.
that's kind of helping because if I just gave you the square root of 1 minus log base 2 of x, I mean, I wouldn't exactly, it'd be a little, I'd have to think a lot about how to graph that, but knowing the inverse, doing the exponential one first, then it helps to graph this.
Okay. Got it. Thank you.
Yeah, so that's actually one piece of advice that just came up that I thought of is if a function is invertible, that's a big if. It has to be invertible to do this. If you're struggling to find a domain and range, you could always find the inverse and find the domain and range of that if it's easier. And then the original function would be the flip of that. But again, the caveat is it has to be something that's invertible in order to do that. Liam.
On the other version of the quiz, I was kind of confused about like the graphing for 1A and 2A.
1A and
I mean 1A and 1B.
1A and 1B. Let me remember what that is. Let me see if I have that quiz in front of me. I don't think I have it on. Hold on. I may have to just look it up on my computer. Give me 1 second. Let me just look it up here. Or you can just just tell me what the first function is.
Okay.
And
It
I'll
was
just put it in.
Yeah, it was log 3 of x squared minus 2x plus 10 and then plus 5.
Okay, let me do a new note. Okay, so and was it find the domain and range and graph or just graph?
Graph, find domain and range.
Okay,
So
so say it one more time to me, log.
log base 3, then
Yep,
x squared minus 2x plus 10,
yep,
and then plus 5.
plus 5. Okay, great. This is a good one to do. So first thing I'm gonna do is figure out what my domain is, right? And for the
Yeah.
domain, you always set it greater than 0, right?
Hmm.
And then, so one thing that I'm noticing here, it's not easily factorable. So, or it's not factorable, I should say. Not easily, not factorable. So then I always test the discriminant just to see if it even has x-intercepts. So 4 minus 4 times 1 times 10, that's going to be negative, right?
Yeah.
So that means there are no x-intercepts. Like, so I'm not going to even bother with the quadratic formula. So if it opens up and there's no x-intercepts, what does that mean about the domain?
All reals.
Yep. So the domain is all reals, which means my range, I'm going to want to find the y coordinate of the vertex because it's going to be
Okay.
above the x-axis. So my range of my log is going to be limited. So let's do negative b over 2a to find the x coordinate of the vertex. And then plugging it back in, we get 1 minus 2 plus 10. So what's that there? 9?
Yeah.
Okay, so the range is going to be log base 3 of 9 to infinity plus 5. So tell me what that would be. 3 to what
That
power
would,
gives me 9?
so 7 to infinity.
7 to infinity. Great, great, because it's 2 plus 5 or 7 to infinity. Yeah.
And then, because when I was graphing, like I was trying to plug in like different points, but then they would just get like weird log
Yeah,
values.
so when you have a quadratic, I mean, it's going to be hard to find nice points. So here would be my advice with this one, because all these tend to be the same when you've got or have the same general shape. When you have it's above the x-axis, so the domain is everything. There's going to be no vertical asymptotes, right? Because it never equals 0 inside the log. So you want to graph that low point. We know the y value is 7. What's the x coordinate of that low point?
Um, would it just be the x coordinate of the vertex of the
Yes,
parabola?
exactly. So we're going to graph 1, 7. So that's my low point. It's not a piecewise function, so it's rounded. But
Okay.
then after that, it's a log function, so it's slow growth.
Okay.
They always look like that.
So then, like on B, it was still like an exponential in the log. So would it be kind of similar?
So B, I think, tell me B, I think it was like the exact opposite what ends up
Yeah.
happening.
It
What's
was
B?
log 2 of negative x squared plus 6x plus 7.
Yeah, so this is one where it will have x-intercepts. It opens down, so it won't have this look.
Okay.
Um, and this is like the other typical one. So if you find the domain, and we can also find the asymptotes at the same time, x squared minus 6x minus 7. So x minus 7, x plus 1. So negative 1, 7. And we know it opens down. So what is going to be the domain here?
Negative 1 to 7 exclusive.
Yes. And the asymptotes are going to be at negative 1 and 7, right?
Okay. Yeah.
So negative 1 and 7. And then I want to find, because this range is because it opens down in here, the range is going to be limited. I know it'll be log base 2. The lowest will be close to 0, but I need to find the y coordinate of the vertex.
Okay.
So if we do negative b over 2a, that'll give us negative 3. So negative 9 plus 18 plus 7, 16.
Yeah.
And so then the range is negative infinity to 4. And that high value of 4 is going to occur at that x coordinate of the vertex, which, oops,
So
negative.
just going to be at 3.
Wait, it doesn't make sense that it's negative 3. Did I write that wrong? Oh, sorry, it's positive 3. Sorry. Because A is negative 1.
Yeah.
It's positive 3. So it's still negative 9 plus 18. Yeah. So sorry, it's not negative 3, it's positive 3. So yeah, it wouldn't make sense for it to be out there. So the high value will be at 3, 4.
Yeah.
And then it's just gonna look like this.
So if it's just a log with a negative exponent, is it just downwards parabola?
It looks like a downwards parabola. It's not exactly a parabola because a
Okay.
parabola would extend to the left and right infinitely.
Yeah.
It looks like a parabola, but it's really just getting closer and closer to those vertical asymptotes. But it does have a parabolic
Yeah.
look.
So, but just like generally, logs with exponents is just going to be the same shape depending on positive or negative.
You mean the logs of a quadratic?
Yeah,
Yes.
quadratic.
Yeah.
Okay.
Yep. Devin.
Hi. Okay. On 513,
Yep.
um, question 14 C of X, I had a question.
Okay, I actually have this one teed up. 5.13 and all the way, you said 14?
Yes.
Yes.
Okay, so I figured out the domain.
Yep.
That completely makes sense to me. But then the range I just didn't get because last unit when we did a lot of these, we weren't able to tell where the high point would be. So I was just wondering, how can you tell where the range is this time and you can't for other times in the unit?
Great question. So let's find the leading term of because inside it's a polynomial, right?
Uh-huh.
So the leading term here would be negative x cubed times x squared times 2x times x, right?
Yeah.
So that will be negative 2x to the 3, 4, 5, to the 7th.
Mm-hmm.
And remember, anything that is an odd degree, the range is normally all reals.
Oh, because it has to hit the thing up top and it has to hit the thing up down.
Yes, because remember, so this would
Okay.
have an end behavior up down. Now, because it's in a log, and you found the domain, I presume, by finding where it was always positive, you're doing 2 plus log base 5 of just the positives of that. But that gets me all reals.
Wait, but if it's up down, wouldn't it have to, so the up part is satisfied because negative infinity to negative 5 works, but 2 to infinity doesn't work. So you don't know between 1/2 and 2 if it's gonna go down to infinity, right? Or negative infinity, right? The
Well, we
dash
don't
line.
care. Well, we don't care, right? Because we made the domain such that I'm only taking the log of positives, right? You
Oh,
you found the domain such that we're just doing 0 to infinity.
okay. So all you need to satisfy is the up part of it. And you know it's gonna hit 0 at some point because it has to cross for an accent.
Yeah, and you know, and you found the x-intercepts. That's how you did
Yeah.
it of the polynomial by doing the sign chart with
Okay.
those. Yeah.
Okay, got it. Thank you.
It was only the one, like if we would be unable to do it if it was negative x to the 6, because then that behavior is down, down, and I wouldn't know the high positive value.
Okay, but if it's odd, we can do it.
If it's odd, you can do it. Yeah.
Okay, great. Thank you.
Jackson.
Hi, Miss Jensen. Could we go over 5.11, question number 11?
511. I think I even have this one teed up. 51111. 511. Oh, yeah. This is the manipulation that you do? Sure. So tell me, so this relies on getting the right setup for 10. So the setup for 10 should have been 0.73 equals, was it a half-life? I'm trying to go. Oh, yeah, the half-life is 1/2 t over 5730. And then you solved for t, right?
Yeah.
Okay, so the question in 11 is saying that is this the same thing? Could I, if this were the setup to solve for t, is that equivalent to that? That's what we're trying to figure out. Are these really, if I solve for t, is it really the exact same thing without actually solving for t using a calculator? So
So,
what's that?
so I understood that. I just didn't understand what you were then asking to for us to do then in that case.
Oh, so what I'm asking you to do is manipulate this equation to make it exactly equal to this. And I can help show you how to do that.
Oh,
Because they are exactly the same thing. And so I wanted you to do the steps to show that. We don't need the one because one is just one, right? I don't actually need that one. But so what I'm going to do is, and tell me if this is, if you agree this is the same thing. I'm going to write it as ln natural log of 2 times negative t over 5730.
so just quickly, you don't have to put the whole term under 5730. It can just be one portion of it.
Yeah, right, because over, so think of this as over 1. Isn't that the same thing?
Oh yeah.
Because when you multiply the across the numerator and across the denominator.
Yeah.
And you're going to see why I'm doing that in a second. Is this the same thing then as, so e natural log of 2, and then doing to the negative t over 5730?
Yeah, it's the same.
Yeah, because a power to a power you multiply. So I'm going from multiply backwards to raising it to a power.
Hmm.
And the reason I did that is, what is e to the natural log of 2?
Uh, 2.
2. And so I have 2 to the negative t over 5730. But isn't that just the same thing as 1/2 to the t over 5730?
Oh, I see it now. All right. Thank you very much.
Yeah, so it was just doing kind of a manipulation to show their equivalent. More using properties of exponents than anything. Other than the fact that knowing e to the natural log of 2 is just 2.
But how did you know, just like kind of more abstractly, how did you know like these were like the proper steps in a way to take to get to that kind of desired answer?
So the only thing I knew looking at this is I was like, well, I know I don't have e in this first equation. So somehow that e has to go away. And then I knew that when you compose a function, when you compose a function with a with its inverse, it undoes each other. So my whole goal was to be able to get e ln of 2 somehow. And so I tried to figure out how I could do it so that I could make e to the natural log of 2 equal to 2.
I see. Okay, thank you.
That's what I was trying to figure out, is like, how can I do this so that I have e to the natural log of 2 and then can replace that with 2?
Okay, so you kind of just like set out on finding e natural log of 2, and then the rest of it kind of just came with.
Yeah, and I just kind of tried things and tried not to break any mathematical rules to do while doing that. Um, but yeah, with that goal of having e the natural log of 2 that then I could replace as just 2.
Okay.
Hello, Devin.
I had a question. So on one of the days we went into class, you had like some problems on the board.
Yeah.
One of them was the whole thing that was like find 3 to the a.
Yes, yes.
And it was like a equals here.
Uh,
Um,
hold on, I
I'm gonna
may have it
yeah.
somewhere.
Okay.
I may not though. Let me see. I have so many papers in front of me because uh I have, when I do warm-ups, I just kind of make them up right before, and so I have a million papers here. Yeah, why don't you tell me? Because I can't find it.
Okay, yeah.
All right, let me. Okay, so find 3 to the a if a is.
It was a big fraction, and the
Yep,
numerators had log 3 of 1
yep,
minus log 3 of 4 in parentheses
yep.
times log 3 of 9 minus log 3 of 2.
Yep.
And then that was over in parentheses log 3 of 1
Mm-hmm.
minus log 3 of 9
Yep.
times log 3 of 8 minus log 3 of 4.
Yep. Gotcha. Okay. How do you do it?
Yeah, so what I tried first doing was just like consolidating
Okay. Yeah.
them because like a lot of them, they're all in the same base.
Okay.
So I
So,
had log 3 1/4
mm-hmm.
times log 3 9/2
Yeah.
and then over log 3 1/9 times log 3 2.
Times log 3, 2. Right.
Yeah.
Yep.
And then I did like some like change of base from,
Okay.
but I wasn't sure if that was the right way to go about it, but I did.
I mean, the good news is there's multiple different ways. So, okay. So tell me what you did.
I did log 1/4 over log 3
Okay. So you did common log. Okay. Got it.
times log 9/2 over log 3
Okay.
over all that over log 1/9 over log 3
Okay.
times log 2 over log 3.
Times log 2 over log 3. Okay. So what were
Yeah.
you going to do from there?
Yeah, and then I was just gonna like switch around. So if you like you can do like the keep change flip thing for fractions. So then
Yeah.
I had log 1/4 over log 3.
Yeah. So all the log threes cancel, right?
Yeah, exactly. So I had log 1/4 over log 1/9
Yeah.
times log 9/2 over log 2.
Okay.
And then I was just stuck here. I had no idea where to go.
Yeah. So here's where I think this may not be helpful is because you want to find 3 to whatever A is to some power A, right? And
Yeah.
if A is something in log base 3,
Hmm.
then that will be nice because 3 to the log base 3 of something will just be whatever the inside is.
Hmm.
You know what I'm saying?
Yeah.
So now you have it in base 10. So I'm feeling like you want to keep things in base 3.
Okay, so do you think we should
So
not have done change of base on the third
yes,
step?
I think you shouldn't have done change to base. Yeah.
Okay.
So buy it, but I mean, it's good to try, but then it's like, okay, where am I going from here? So I might instead, well, there's different ways to do it. I mean, you could do what you started out doing. Whoops, I didn't mean to erase that. Started out doing here.
Hmm.
What about actually, before you combine logs, what about changing things that you actually can evaluate to numbers, right? Because log
Oh,
of 1 is 0, right?
yeah.
So try that first and then see what you can do from there.
Wait, sorry, where's their log 3 of 1?
Like go back to this right here.
Oh, okay, got it.
So go back to the original, and I would maybe evaluate the ones you can evaluate right away,
Uh-huh.
and then and then see what you can do after that.
Okay, I'll try
So
that.
try that for a minute, and then I'll come back to you.
Okay, thanks.
Nilesh, back to you.
Hi, I was wondering if we could go over like the proof on 5, 9.
Proof on 5, 9. Yeah.
It's number 27 and 28.
Okay, I'm
The
gonna.
whole stretch and smush thing.
Oh yeah. Okay. Oops, I didn't mean to do that. 5, 9. I'm gonna open it because it's easier because there's a lot of words if I remember on this one. So I'm just gonna open it. 5, 9. Um, it's towards the end, isn't it?
Yeah, it's a less problem.
Okay. Oh yeah, this one right here, right?
Yeah, the bottom two. Yeah, yeah.
Yeah, so 27, the only thing 27 was asking was show that log base b of x is some sort of vertical stretch of common log of x. And to do that, you're just going to rewrite, because I want to relate it to common log of x. So let's use the change of base to rewrite log base b of x. So we can rewrite that as log x over log b. Do you agree with that?
Yes.
And that's remember, b's a set number greater than 1. So b's not changing. We're assuming b is some number greater than 1. So I can rewrite this as 1 over log b times log x. And whenever you do a number, say, let's just call it c times a function, that's a vertical stretch. And that's what I have here. I have some number. This is the number, 1 over log b times my original function. So this is just equal to c times, actually, we'll call it g of x because that's what it is. So that's what a vertical stretch is. So does that make sense that it is a vertical stretch? Okay.
Yeah.
So now we've got to reason out for what values of b will it actually be a stretch versus a smush. And so remember, you're dividing by log b, right? And b is greater than 1. And so I would test something out. So let's test out, pick a number greater than 1 that you want to test out.
2.
2, sure. So 1 over log 2. So let's think about what log 2 is. It's 10. You're asking yourself 10 to what power gives me 2? What type of number is going to give you a value that's less than 10?
Some number between 1 and 2 and close to 1.
So it's going to give, well, it won't be between 1 and 2, right?
Or actually, it'll be between 0 and 1.
Yes,
Yeah.
that's exactly right. So this is going to be a number between 0 and 1, so a fraction less than 1. So when I do 1 divided by a fraction less than 1, am I going to be multiplying by a number that's going to stretch the graph or smush the graph? So say it was like 1/8. 1 divided by 1/8 times log x. So what is that going to be doing to log x?
Oh, it's going to be stretching it.
Right. So I know for 2, so if b equals 2, we're going to be stretching it. At what point will we get a number that's going to be greater than 1? So I'm going to be dividing by 1. I'm going to divide 1 by a number that's greater than 1. What would b have to be greater than? So think
10.
Yes, exactly. Because log 10 is where it equals 1, right?
Yeah.
But what about if we did log like 11? Log 11 is going to be a little bit greater than 1. And so that means I'm going to be multiplying log x by a fraction.
Okay.
So it'll be a stretch when b is between 0, not 0 and 1, between 1 and 10. That'll be a stretch. And it will be a smush when b is greater than 10.
Okay, thank you. And just as like a reminder, could you like explain to me what do you mean? What do you mean when you're like saying stretch and smush?
Yeah, so it means, yes, sure. So stretch means like, so any vertical something, it means you're multiplying the y values by something. And so if I think of, let's just take a basic example here. So say I had that and do something like this, something really random, 2, 1. So say it was 2 times this function. That means all y values are being multiplied by 2. So it's going to stretch the graph in the direction of the y-axis, so away from the x-axis. So this 2 would go to 4, and this 1 would go to 2. So vertical stretch means it's stretching it in the y direction away from the x-axis. It almost makes it look skinnier sometimes, depending. Whereas smushing means I'm smushing my graph closer to the x-axis because the y values are shrinking.
Okay.
And the
Yeah.
reason it's close to the x-axis is guess what isn't changing? Anything
Anything that's inside, like all like the domain of vectors are like
those aren't changing, but also the x-intercepts aren't changing because zero, if a y value is zero, 0 times anything is still going to be 0. So that's why we say it's stretching away from the x-axis because anything on the x-axis is staying, but everything else is going away from it.
okay. Got it.
And so
All
with the horizontal stretch and smush, it's either going away from the y-axis or towards it, because in that case, the y-intercepts aren't changing.
Okay, thank you. That makes sense. Yeah.
All right, Devin, we're back to you.
Yeah, okay. So I did what you said to do,
Yeah.
and I'm a little bit stuck again, but I think I'm pretty sure it's the final part.
Okay.
Okay,
Let me find it. There we
yeah.
go. Yeah. All right. So tell me what you ended up getting, or where
Yeah. I had 2 minus log 3, 2.
A equals. Okay, perfect. Okay. Now make this a single log. So change 2 to log base 3. What is 2 in log base 3?
Log 3 of 2.
So log 3 of 2 wouldn't equal 2. What log 3 of
Oh,
what would give you 2? Like 3 to what
um,
power gets you 2? Think of it that way.
well, it would be somewhere in between 0 and 1.
Isn't it 9? Doesn't log base 3 of 9 equal 2?
Oh, yeah. Okay, yeah.
So you want to think of what would, when I evaluate the log, 3 to what power gives me the number 2, and that would be 9. So you could rewrite 2 as log base 3 of 9.
Okay, so the answer is just 9 halves.
Yes, right.
Okay,
Yes,
got
because then you would do 3 to the log base 3 of 9 halves.
it. Okay, cool.
Wrong.
Can we go over one of the things you put on the whiteboard today? It
Yeah.
was like solving for the domain and range of 2 minus log base 2 of x plus 1 over x minus 2.
Oh yeah, I remember that one. Okay. So it was y equals 2. Is it say the problem again?
2 minus log base 2
Yeah.
x plus 1 x minus 2.
Like that, right? Yeah, so the domain with logs always start the same way. Set up the inequality, and hopefully we recognize, oh, a rational inequality, I got to do my little sign chart where the numerator and denominator equals 0. Remember, it's greater than, so there's no filled in circles. And it will be the extremes.
Yeah.
Okay, so the domain is negative infinity to negative 1 union 2 to infinity. And now let's think of, remember, always start with what's changing. So let's think of if I were just working with this. So forget it for a minute that it's in a log. If I were just had this as a function, it would be everything except when I see x over x, what do we want to think?
K problem.
Yes. So let's figure out what it can't be. So x plus 1 equals kx minus 2k. So what can't x be?
Negative 1/2.
Careful. It can't be when the x's cancel. What would make the x's cancel?
Oh, if k were 1.
Yes, right.
Okay.
So it can't be 1. The other kind of thing that you can now think of, now that we graphed rational functions, you can also think of the k problem as when we graph this, it would have a horizontal asymptote at y equals 1. And that's where, and it's not going to cross that. So the range will be everything but that horizontal asymptote. That's not
Okay.
about it. So if I were just looking at that rational function, this would be my range.
Mm-hmm.
But now I go back to the fact that I'm in a log. Because I'm in a log, what's the smallest I can take a log of?
1.
Well, I can take less than 1, but it can't be less than,
Oh, 0.
yeah, right. So
Okay.
it's not going to negative infinity. The lowest is getting super close to 0. I'm excluding 1 and then 1 to infinity.
Oh, okay.
And then we can go through this process. So 2 to what power gets me close to 0? Negative infinity.
Mhm.
2 to what power gets me 1? 0. The mistake people make sometimes there is they do 2 to the 1, but remember you're doing a log. Log base 2 of 1 is 0.
Mhm.
And then 0 to infinity, and then just do 2 minus all that. So it's going to be negative infinity to 2, 2 to infinity.
Okay. Okay, cool. Thank you.
You're welcome. Leah.
So on the makeup quiz, it was like leave your answers in common log.
Yeah.
So if I wanted to take the log of both sides,
Yep.
but it was like 4 times 3 to the x plus 5, how would I take the log of that?
Perfect. Great question. So if I take the log of this, right? That was on one side, right?
Yeah.
I can't yet bring the x plus 5 down, but what I can do is I can separate multiplication in a log to
Uh,
addition in separate logs.
okay.
So that's the extra step you have to do there.
And
And
then, oh, sorry.
and then you can bring that x plus 5 down. And the other thing to remember is that's just a number. So just distribute it through.
Okay. And then you just solve for x with,
Then you bring everything with x on one side and everything else on the other side, factor out the x.
okay. Thank you.
Yes. Yeah, so that's why do this step. Don't do it in your head. Actually write this down. So then hopefully you'll recognize, oh, wait a second, I can't bring the x plus 5 down. So I have to separate out the 4 and the 3.
Okay.
This is, let me see if I can find it. Again, I just mixed up, but I wanted to show you because I put this up on the board for C block. I made these up but I think they're interesting. Just a few more of these, so I'll put both of them up. So it was another solve, and they were these two inequalities. Because we don't have too many of these, and I am going to give you something like this, so it's worth giving it a go. So solving those two inequalities. Again, if you're in C block, these are the two that I put on the board. So people can try that, and anyone who has a different question can ask too while people try these two. I'm trying to say, are Ryan and Morgan still on? Can't see.
Yeah.
Now, so I
Yeah.
found the problem that I normally give that you guys asked at the beginning. It was the same setup, but instead of asking what log base 2 of x is, I usually ask what log base 2 of x squared is. The whole thing squared, which is easy enough to find. I mean, in some ways, log base 2 of x is harder, but you just do one step less. Um, anyway, actually, I was looking for that problem. Have people gotten the first one yet? You got a question for me, Nilesh?
I have the answer for the first one. Should I? I was wondering.
Are people ready to hear an answer? Let me ask you this. How confident are you in that answer? If you were to give me 100%, 0% to 100%.
Like 85?
Okay, okay. Would you be willing to bet 5 points on the test on it?
Um,
Meaning if you don't get it, I would subtract 5 points.
no, no,
Just
not
joking.
that confident.
I'm just joking. I wouldn't do that to you. No, I'm just joking.
Feel free to give me 5 points though.
Okay. Just for being brave enough to play the game.
Yeah,
Okay.
yeah. Takes a lot of courage.
It does take courage. Okay, oh, I'm losing my iPad. All right, let's tell me what you got.
I said X has to be less than -7.
Thoughts. Do we agree? So you're saying negative infinity to -7.
Yeah.
Rafe?
I got -7 to 1.
All right, so Rafe got something different.
Yeah, that's what I got as well.
Yeah, I got that too.
All right, what do we think, Nilesh?
Yeah, no, I probably got it wrong.
So I like -7. So take me from -7. What did you do after because you find equality first, right?
Yeah.
So I'm all with you there.
Yeah. So I just did what I thought you'd like pick a point on either
Yeah, so
side.
pick
And,
what did you pick to test?
I picked uh -1.
Okay. So if you pick -1, so I have a feeling is -1 to the right or left of -7?
To the right.
Okay. So x equals -1. So if I test that, you're doing log base 2 of 2,
Yeah,
which is what?
1.
Is 1 less than 3?
Yes.
Yes. So isn't it gonna work?
Oh shoot, yeah.
So it does work. Yeah. So you
Yeah.
did all the right things. So greater than -7. Why can't I just say to infinity? What's the domain of this baby?
Oh, it's the X has to be uh greater less than 1.
Yes. So that's why there's a cutoff at 1.
Oh, so I also have to apply the domain to the thing?
Yes.
Okay,
Right.
got it.
So always, because all your answers have to be within the domain. If this had been the answer, then you don't have to worry about that because it already was all in the domain. But because it was on the other side, it got cut off.
Okay, got it. Thank you.
And you have to restrict the domain because when you're solving for the possible values of the domain.
Well, so when you're solving for all values of x that make the inequality true. But remember, x is in a log. So you have to be able to take the log of it too. So when I'm sign testing, I'm just figuring out on what side of that number works. But I also might have to restrict it further to make sure I'm in my domain. So in other words, think about it. You want the overlap of the domain and that inequality solution because it has to be able to do it. And you have to be able to take the log of it. So it has to be a log of something greater than 0. Yeah, Liam.
So I was taking the common log of like 2 to the x plus 4 to the x. How would I simplify that? Like, could I separate or how
Oh,
would I-
this is a different problem?
Yeah.
I was like, how did you get to that? Okay, you're taking the common log of what?
2 to the x plus 4 to the x.
Yeah, you can't do that because you can't.
Okay.
Yeah, so that would not be the way to go. So whenever I see some weird variable things and plus, I'm thinking this may be a good U substitution problem.
Okay. So then just substitute like for 2 to the x and then
Yes.
okay, thank you.
Anyone get 2?
Yeah, I got 2.
Okay, who's talking here? I can't see. Who said yeah?
That was me,
Wait, who's me?
Darius.
Oh, Darius, sorry. For some reason, normally the person who's talking, their names comes to the top of the scroll. So gotcha. All right, Darius, what do you think?
Can we wager any test points on this?
No, we won't wager any points. But you can it'll be a source of pride if it is correct.
Is it
You
x
took-
x
Go
is greater than 2?
X is greater than 2. Or so 2 to infinity, in other
Yeah.
words. Okay. Other people want to weigh in?
Oh, I agree.
X 2 x plus 2. You agree. Okay. Anyone not agree? All good? Nice. All right. This is actually meant to do one that was harder. So last one. Actually, right. The reason I asked surprise is I was like, wait, that doesn't match my answer because I meant to write this instead, which is a little trickier. So take a couple, and this will be our last thing. Take a couple minutes. So sorry I had hesitated, Darius. I actually wrote down the wrong problem. But nicely done. All right, who wants to be brave here? Anyone want to give it a try?
Sure.
All right, what did you get?
I got -2 to -7/4.
-2 to -7/4. Anyone else? Or other thoughts? Rafe.
I got -7/4 to infinity.
Okay. Darius, you agree with which one? Are you just clapping for them all? Was that Darius who clapped? I can't see. Yeah. Or are you not going to say? Unclapping. Okay, should we go over this one? You Rafe, yes. Or are you not raising your hand anymore?
Yeah, I meant to lower it, but
Okay, got it. Sorry. Okay, let's go over this and see who's right here. So first you do the equality, and it looks like you both agreed that you got -7/4 when you did equality. Yeah? Right? So you did 1/2 squared, which is 1/4, equals x plus 2. So x is 1/4 minus 2, or -7/4. Yeah? So -7/4. And then let's test. What's a good number to pick? what about picking -1 for x, which is over here? So if I pick -1, log 1/2 of 1 would be what? If I plug in -1 for x, log base 1/2, I'd get log base 1/2 of 1, which is log of anything of 1.
Yeah.
0. Is 0 greater than 2?
No.
No. So we're not on that side. So I've got to be less than -7/4, but let's just check my domain. I've got to be greater than -2. So it's going to be -2 to -7/4. That'll be the answer. Does that make sense, Rafe?
Yeah.
Yeah, just be careful when you pick a number to plug in. Just double check that that is indeed makes it a true or false inequality. Yeah, so it's tricky, especially these ones are tricky, some of these. Yeah, so just make sure to double check these. Okay, so oh, Rafe, yep.
Well, I plugged in 0, and then I got log base 1/2 of 2, and then wouldn't that just be -1?
Yeah, is -1 greater than
Oh, yeah. Okay. Yeah, my bad.
You'd be right if it was less, but yeah, you did you did get it. -1 is right. It's just not greater than 2. Okay, so we have tutorial tomorrow. If you guys have any other questions, I feel like you're in good shape though. I'll see you tomorrow.
Thank you.
Thank you very much.
Bye, guys.
Thank you.
Thank
Thank
you.
you.
Thank you.
Thank you.
Thank you.
You're welcome.